everyone. So this is Professor Gyanendra Tiwari. Uh, why I am good for this position is because there are two perspectives how I look at this opportunity. Number one, am I qualified for this? So yes, I am qualified for this. I have done my bachelor's, BTech, and MTech in computer science and engineering, and currently pursuing my PhD in computer science and engineering itself. So yes, I am qualified for this. And the second thing is, am I suitable, or do I have experience for this position? So yes, I have experience. So since last 13-14 years, I am in to higher education. I am teaching engineering students in various universities and various institutes across the country. So yes, I am qualified as well as I am experienced for this particular position. So here mostly I'll be discussing about the concepts which generally they used to ask for gate examination, right? So if I go through the concept once, so or the content what I'm going to cover in this entire series once. So this is the proposed course module which I am going to cover. So I divided this entire thing in 5 modules, and this 5 module covers the concept of data structures and algorithms, right? So what I tried is to start with a point where even the students do not have much exposure of what data structure is and what are the various notations we represent the time space complexity and all. So even students are not aware with those things. Still what I tried is to start with such a level that everybody is able to cope it up, right? So the first module which I plan to cover in the first 20 hour of the course consists of the introduction to algorithm. So basically there I'll be talking about what algorithms is and what are the properties of algorithm. Then we will be covering the basic concept of analysis of the algorithm, like how do we analyze the performance of algorithm, right? So it basically mean the time and space complexity. So all the three major notation and the three minor notation I'll be covering here. So theta, omega, and big O notation we will be covering in this particular topic. Then we'll be talking about how to calculate the time and space complexity for the algorithms, like a brief introduction of recurrence tree method, backpropagation method, and the master theorem. So these things I'll be talking initially. After that, we will be talking about some simple sorting algorithms like heap sort, cell sort, and other comparison based sorting algorithm like insertion sort, selection sort, these things, right? I'll not be covering here the merge sort and quick sort, because that I plan to cover in divide and conquer strategy when I'll be talking about divide and conquer. Then I'll be talking about merge sort and quick sort, right? So after that, I'll be covering the basic data structure which one must know before I begin to go in depth of the complex data structures, or I would say advanced data structures. So I'll be covering stacks, queues, basic trees, right, like binary search tree and all. Then we'll be covering at least one BST, height balanced BST like AVL tree, and if time permits, we'll be talking about red black tree as well. Then we'll be talking about what is amortized analysis, right? So how do we calculate the overall time complexity for some data structures? And in that, I'll be talking more about Fibonacci heap and binomial heap, right? That makes sense out of it. Okay, then again, few very important data structures which is required for explaining almost everything in DSA, that is priority queue, disjoint set data structure, which we'll be needing when we'll be talking about Kruskal's algorithm, right? So here I'll be talking about disjoint set data structure and the basic operations on disjoint set data structure. With this, our first module will finish, right? Then in the second module, I have mostly kept all the advanced data structures and the basic of divide and conquer, right? So here I'll be starting with basic tree traversal techniques like depth first search, breadth first search, right? And after completing this depth first search and breadth first search traversal, I'll be moving towards the advanced data structure topic, right? In advanced data structure, basically, I'll be coming back to height balance binary search tree. AVL tree we already talked about. So now we'll be talking about red black tree. Then B trees are very important because this is the data structure which is being used in database management system as well as in data structure and algorithms course also. Then I'll be talking about these binomial and Fibonacci heap and skip list. So we already have been by this time we already have been talking about this binomial and Fibonacci heap. At least the introduction I would have given in unit number 1 when I was talking about amortized analysis. Here I'll be talking about the basic operations which and I'll be going a little in detail about these data structures, right? After this two small data structure, which are sometimes important for some problem solving, like tree, tries, and skip list. So these I'll be covering. After this entire coverage of basic and advanced data structures, I'll be starting the algorithm paradigm, right? So first and the simplest algorithm paradigm I'll be starting is divide and conquer, and in divide and conquer I'll be mainly covering merge and quicksort, right? And then there are some other algorithms like expressions matrix multiplication, and binary search, simple search, binary search algorithm and all. So with that, we'll be finishing our module number 2 again. This module I plan to complete in next 20 hours. So by this time we have already been covered 40 hours of our course, right? So and then I'll be moving to module 3, and I'll be mostly focusing on the different algorithm design paradigms. So next I'll be moving to greedy. So greedy, all graph algorithms I'll be covering here in greedy. The knapsack problem, the MST, Prince Crystal, job sequencing, with deadline and all. So these things comes in module number 3, and it is comparatively a shorter module. And that's why I planned to cover it in 10 hours, right? Then in module number 4, I'll be covering dynamic programming. So this is considering this is one of the most important and most talked about uh, problem solving approach. So here I'll be initially giving the idea of what is top down and bottom up DP, then tabulation, memoization, these things, basics we'll be discussing initially, and then I'll be discussing some problems which are based on DP, right? Like Digestra, all-pair shortest path, Floyd-Warshall algorithm. So Digestra is not DP, so it is in greedy, right? So basically DP and greedy both I kept here. So Floyd Warshall is DP, right? Then we will see 0 1 knapsack problem here, right? Then we'll see Floyd Warshall algorithm here, traveling salesman using DP, using backtracking, and using branch and bound. All three we will be looking in this course. But here in module number 4, we will see traveling salesman using dynamic programming, right? So that will be our the fourth module, and that I'll be covering in around 12 hours. Then the last module, the fifth module, is mostly about the advanced, or you can say the less used algorithm design paradigm like backtracking, branch and bound, and all those things. So here I'll be again talking about the knapsack problem using backtracking, using branch and bound, and Quinn problem using backtracking, right? The sum of subset problem using backtracking, graph coloring problem using backtracking, right? Hamiltonian cycle problem. So all these uh, NP class of problem, NP hard class of problem I'll be discussing here. Again, and after completing all these branch and bound and backtracking algorithms, I'll be moving towards the end of this course, where I'll be talking about the much talked and I would say confusing topics of this course, that is NP, P, and NP class of problems. And with that, I'll be finishing it off. Right. So that is what is the plan to cover in this entire discussion, entire syllabus. So I hope this journey will be quite enjoyable and quite joyful for all the students. Thank you. Thanks a lot.